Welcome back to Lecture 2 Biomes Part 2. Let's get right to it. So remember the objectives from last time were to look at various different biomes, 6 of them to be exact, and their subbiomes. So we learned about the first 3, and that was the forest. Then we looked at freshwater and marine. Today we're going to examine the remainder of those biomes, starting with tundra as biome 4. A little bit about the tundra. Tundra comes from the Finnish word tunturi, meaning treeless plain. So what is a treeless plain environment? One of the things that's most important, and obviously a really good test question, would be that tundra has permafrost. Permafrost means that the sublayer of soil is frozen throughout a majority, if not all, of the year. Very few places in the earth have permafrost. So if you're in an area of tundra, permafrost is dominant. Permafrost in the tundra, specifically tundra, exists and covers 1/10 of the Earth's surface. That's a lot of permafrost. I'm going to link that to the last few lectures of the semester talking about climate change, because as permafrost melts, all the carbon-based living material that has died and has been kept frozen in the tundra will melt, releasing methane and carbon into the atmosphere. That has potentially devastating consequences if and when that should happen. We know that the tundra has cold temperatures, very windy. That's one reason there's few plants, and with what are plants are shrub-like plants close to the ground, offering shelter to animals. We know that tundra exists in both polar regions, not just in the northern hemisphere like taiga. The snow melts seasonally and annually, producing an incredible amount of ponds and lakes. If you review, the name for lakes was lacustrine. Precipitation is very low, almost like a desert, 10 to 25 centimeters a year, and that varies based on what latitude of tundra you may be existing. There's high populations of specific organisms that live in the tundra, but very limited species diversity. So a lot of the same things, for example, snowshoe hares, a white bunny, they live in huge quantities in the tundra, and so do their predators. But there's very few of the various different types of species in that neighborhood. In terms of plants, you should see a very shallow root system and very simplistic plants that are able to withstand high wind conditions. There are poor nutrients in the soil, and the most common ones being nitrogen and phosphorus. The tundra is always on the move. What does that mean? Very, very short growing season, which means that you're going to have a variety of organisms come in and out of that environment, meaning the tundra environment, throughout the year. There's a limited food web, and many animals and species are migratory. That's what I meant by they move in and out of the area. During the summer, you'd expect to see a huge amount of seasonal insects, a very common problem in the tundra region during the summer months. It's a common place to have waterlogged soils in the summer because of melting permafrost at the surface. The bogs or the wet soil areas and standing water support insects and other creatures that live in the area throughout the summer months. When you look at the tundra, we're in the coldest and we're in the driest, or one of the driest biomes in the world. So there are 3 sub-biomes of tundra: ice, Arctic/Antarctic, and then the Alpine. We're going to cover all 3. The ice, known as Continental Glaciers, these are the things that cover the North and the South poles. Continental glaciers get their name because they cover large continental areas such as Antarctica, Greenland, and at one time in geologic past, that's not just once, but many times, parts of the world have been covered by continental glaciers. The most recent continental glacier epoch occurred during the Pleistocene epoch, And that caused glaciers to come down from Canada into North America, all the way into farthest south into the United States would have been upper part of Kansas, Wisconsin, the Dakotas, down into the New York area. So this subbiome is hard to classify because it's a biome, but yet it's not. It consists of animals that live mostly on polar, glacial, and sea ice. These are in this area, you'd see absolutely no plants, only migratory animals like polar bears, penguins, seals, the things that mammals you'd expect to see living in Arctic and Antarctic situations. Today, the only ice, quote unquote, that we have that are continental glaciers currently exist in Antarctica and Greenland. When you think of continental glaciers, people just think it's solid ice. But I want to kind of reframe and reshape that paradigm you may have of continental glaciers because they're fairly active systems. During different parts of the year, you'll see glacial streams, and as climate change occurs, you'll see more fresh water leaving continental glaciers, causing calving. Calving is a term applied to ice that breaks off of glaciers into water bodies. The Arctic and Antarctic is the second subbiome of our tundra. It exists at the polar circles. Soil is often filled with the moisture like a frozen marsh. Animals' survival strategies revolve around constant migration to find water resources and food resources. So this is kind of a satellite view of various different ponds that you can see in these regions. That's one reason Alaska is the state of 1,000,000 lakes. It looks just like that. Plants live and die quickly during the few annual weeks when it's not below freezing. Having said that, their remains can often be preserved for thousands, if not hundreds of thousands of years in permafrost. Having said that, their remains can be captured in the ice from biodegrading for thousands, if not hundreds of thousands of years. So when it finally does warm up, the carbon and methane that is in those biological organisms will decay, causing an accelerated climate change problem. There's a 50 to 60 day growing period in this subbiome, and at least 25 to 90 centimeters of the soil is frozen in permafrost across the entire year. Often these areas are rich in hydrocarbon reserves, making the North Pole in particular one of the hottest spots for various countries looking for the next future oil reserve. Something more about the Arctic and Antarctic subbiome is there are two seasons, winter and summer. There's nothing in between. Winter temperatures just frigid, minus 20 degrees to minus 60 degrees Fahrenheit. Minus 20 is the warm side of winter. And on the summer side, we have 35 degrees up to 55 degrees Fahrenheit, much more endurable. Winds blow excessively during and around the Arctic and Antarctic areas. They blow 30 to 60 miles per hour fairly steadily. An average of 15 to 25 centimeters of annual precipitation occurs, and most of that actually drops during the summer months, but the ground cannot absorb moisture because it's frozen. Remember, it's permafrost. Since the area is usually flat, the melted snow just sits there, then refreezes during the following winter, allowing glacial ice to grow and shrink. The third subbiome of tundra is alpine, my personal favorite because alpine glaciers have just dramatic landscapes. Sometimes this is referred to as the tree-lined tundra. I can remember going on a trip to Denali National Park, and what used to be Mount McKinley is now called Mount Denali. President Obama changed its name during his presidency. And I can remember we were there looking at Mount Denali and also taking a ecosystems tour, a nature tour. And we were on the tree line for the tundra, and the park ranger pointed that out. There were places that you could see definite alpine trees and then the barren landscape right beyond it. And then there was a kind of fuzzy area in between that was a mixture of both, and that's the tree-lined tundra. This doesn't follow any climatic scheme because it relies on altitude and can occur anywhere on the planet. In the Alpine area, we get unpredictable rainfall amounts, and as you ascend up a mountain, the Alpine tundra is typically preceded by conifers. As you involve with or look for life, you will see that most plant life involves wildflowers, mosses, and lichens. High alpine regions can produce ecological wonders similar to an island ecology. So basically, as you're hiking up and down, for example, the Grand Canyon, you can actually start in alpine when you're up there in the top of the North Rim and end up back on the other side and have gone through multiple ecosystems. It's rather remarkable. The average summer temperatures typically range from highs of about 50 to 60 degrees Fahrenheit, very tolerable, and their lows at or below freezing. They have a 180-day growing season with very well-drained soils that tend to freeze at night, even during the summers. So you get a very beautiful, spectacular scenery as you see over here. The winters can last from October through May, depending on the location of the mountains. Animals vary from mountain goats to coyotes and anything that will live in the alpine glacial neighborhood. Alpine snowmelt accounts for one of the primary causes of sedimentation in freshwater as land is eroded. Let's look at grasslands, which is Biome 5. What is a grasslands? These are difficult to categorize because the lands are dominated by grasses and miniature shrubs, which are limited in trees. Grasses initially evolved within cooler climates but have adapted to warmer regions. Back during the 30 million years ago, we had an expansion of grasses, certainly by 20 million years ago, and that supported a gradual change from a warmer climate during the Eocene to a cooler climate all the way through the Pleistocene, which is the last ice age. Ecologically speaking, we support a large mammals and grazers in grasslands. So you see a lot of hoofed animals and their predators. Average rainfall does not typically exceed 100 centimeters, but that's variable depending on which subbiome that you're in. This is a fragile biome, very extremely fragile, because it's a threatened ecosystem because of agricultural developments and limited freshwater supplies. When you see a pictorial overview of biomes and you find the grasslands, we're going to start right here, savannas. This is the area that we're going to be looking at for grassland. So let's look at the grassland subbiomes. Tropical grasslands. Yes, indeed, there is tropical grassland areas. This is called the tropical dry forest, savanna, or tropical grasslands. They are mostly dominated by grasses with few scattered trees, and they produce almost an oasis effect where tree lines are found around groundwater springs. Tropical grasslands cover half of Africa, include sparse portions of Mexico and even South Texas. When we think about tropical grasslands, they have very porous soils that drain water well, just the opposite of what we learned about one of our other biomes earlier in this first lecture. They have high amounts of porosity, which means they're pretty sandy, but very limited amounts of organic matter or O matter at the top of their layer. So the soils aren't very nutrient enriched. They commonly have a wet and dry season that coincide with seasonal weather. Tropical grasslands have 85 to 150 centimeters precipitation annually, and most of that drops in one sequence of time called monsoon season. The average temperature in the dry season is around 93 degrees Fahrenheit, and the average temperature during the wet season drops to 61 degrees Fahrenheit. Most grasses in these areas have long tap roots which can reach deep in the ground in search of groundwater as a source of survival. This area is also prone to fires, though not to the same level as the chaparral that we'll investigate a little later. Most animals here are hoofed or large predators that feed on our hoofed grazers. Sometimes this biome is also referred to as the Serengeti in Africa and the bush in Australia. So this is a shot that I took in Australia of a kangaroo. This would be the bush. So this is a tropical grassland. Isn't that cute? You just want to take him home, right? He's just adorable. Unfortunately, in this watering hole, I would be a little scared if I was this giraffe's mom that a hippopotamus might be nearby. So when my dad was in the ICU for a heart attack, I had to watch this show over hippopotamuses like over and over and over because it was the only thing showing. And a mommy should really take note of that because water during the dry season, hippos are going to be hanging out there. And that's not too good. Being attacked by hippos is a bad thing. And hippos, while they are herbivores, protect their water resources. So these are the animals that you would expect to see in a grasslands environment. This is what you would think of as the Lion King area. When we think of tropical grasslands, you can see that most of it exists in Africa, which is super important because as desertification occurs in that area, we have a real problem with it expanding into grassland areas, which are putting animals out of their habitat. A very difficult thing to address long term. The second subbiome for grasslands is called the temperate grasslands. This is also referred to as the prairie. They are very limited in trees and shrubs as compared to the other two types of grasslands, with grasses that can vary between 3 to 6 feet in height. About 100 or more years ago, in south area of the United States, especially in Texas, New Mexico, that area, we used to have grasses that were 6 foot tall called blue stem grasses. And as settlers moved west looking for gold, they basically demolished the blue stem grass. So grass became shorter, and it certainly is today. You can still see some long stem, but as you look at the prairies here, that's classic temperate grasslands. The temperate grasslands receive 75 to 25 centimeters a year of annual precipitation. They're very rich soils and high levels of minerals, and that's different from what we just saw in our tropical grasslands. They have extreme temperature changes from below zero all the way to above or over 100 degrees Fahrenheit. And that's been an adaptation on grasslands after the last ice age to try to deal with the change in climate. In North America, they represent some of the biggest influences on extreme weather systems, on how weather systems actually move through prairie lands. Only 47% of this biome remains globally. 90%, however, of the natural prairie is gone in the United States, which means the animals, prairie birds, prairie dogs, things of that nature, have lost their natural habitat. Most of these regions have either been grazed by livestock or converted into farmland, and few true prairie lands exist. However, some are protected as public lands. Where do you find temperate grasslands? You find them north of the Tropic of Cancer and south of the Tropic of Capricorn, specifically in Central North America, South Africa, Southeastern Europe, Southeastern South America. So this is a very finite area to find temperate grasslands. See where it's kind of in the middle of the hodgepodge for temperature, but low in precipitation. When we look at the temperate grasslands around the world, you can see that it's very specific to certain areas. Almost the entire middle section of North America used to be a ginormous grasslands. Some of it still is. When you think about the Dakotas, you think about Nebraska, but we have converted so much of that land into agriculture. When you see what's in Europe and Asia, it's dominated by grasslands. You can see the Serengeti down here. The third subbiome is called Chaparral, and this is commonly seen in North America in the state of California. This biome is sometimes referred to as the Mediterranean or sagebrush. Sagebrush is the right term that we would apply in the United States. I like to think of it as a crossbreed between a grassland and a desert that has very unique places. It's difficult to categorize, and here's why. It has lots and lots of short shrubs with some grasses and few scattered trees. So it's a weird grasslands. It averages about 25 to 50 centimeters of annual precipitation of rainfall. It has mild temperatures year-round. So you think about the chaparral, and some pretty famous places in California would qualify as chaparral. Very beautiful places indeed. California, Argentina, Italy, and even parts of Texas can qualify as good examples of this subbiome. The ecosystem is built to burn on purpose. Nature made it that way because it cannot sustain the same plants for more than 30 years. Some plants in this region only sprout after a fire occurs, and that allows for the most nutrients available to germinate in the region. More fires occur in California as compared to other locations, and those directly correlate to the chaparral biomes. If you're considering moving or already live in California, think about not selecting the chaparral as your home, or get really good insurance for fire. So when we think of chaparral, you can see a hint of it here, lots of it down in South America, southern tip of that. Then you see the rest of it in these areas. It's a very limited and probably most narrow in terms of locations on the earth of all the biomes that we'll look at. Let's get to deserts, which is biome 6. We refer to deserts as another new term for many of you called Aeolian, and I'll say that again, Aeolian. Aeolian actually means wind or desert. So Aeolians or deserts cover 20% of all land on Earth, and that number is expanding. Technically, any area under 25 centimeters of annual rainfall could be classified as a desert. Natural disturbance factors in a desert involve intense flooding. So flash flooding is the number one scare thing that you should be afraid of when you're in the desert. Brief freezing temperatures and sometimes even fires. But flash flooding is always my biggest concern when we take students on the geology field course all throughout the Southwest, because these things can happen and you have absolutely no warning time to get to safety. Deserts commonly support small plants and some conifers. So this area right here is a great look at what near Hanksville, Utah, where the Mars Desert Research Station is located. This is saguaro cactus over here. By the way, their arms grow very, very slow, like a couple of inches max a year. The soil is often gravelly and rocky that does not retain much organic and nutrients. As a matter of fact, it's made up of something called desert pavement on the top. That's where the ground layer actually looks like it's been cemented together and the rocks look like they are glued together. That's a natural geologic process. So desert pavement prevents infiltration during storm events. Deserts as a biome experience extremely wide temperature range, varying from minus 20 degrees Fahrenheit to up to 134 degrees Fahrenheit. I took my mom on my sabbatical years ago to Death Valley National Park, and it got up to 128 degrees while we were there. There was a heat warning. They had hiking completely off limits. So if you've heard of sliding rocks, you couldn't go look at that. And I had my laptop sitting on a cushioned surface for less than a minute trying to get some video of the sand dunes that are there, and it shut down to heat my computer, my MacBook. So I can testify that deserts get hot. Deserts are considered the least productive biomes in terms of living organisms, even under oceans and tundra. So don't estimate that they have living life, because they do, but it's going to be different from what we see in the rest of the biome world. Humidity and water vapors are scarce and very low. So you typically have a high pressure weather system that exists in the area for a long stretch of time. Fauna in the warm deserts mostly consists of reptiles and a few small mammals. So if you don't like reptiles, the desert's not a place for you. Most animals in the desert will burrow because the heat's too high during the day, so nocturnal or nightlight becomes very prevalent in the desert. Most have slender bodies with long limbs and have thick skin with waxy coatings to help them actually retain what moisture they have in their body. Many possess special eyes and eyelids that protect them from dust and sand, and most are, as I mentioned, nocturnal and preferred shade over the open sun areas if they're out during the day. When you look at deserts, we're going to be looking at these sections right in here. So we're starting to get to the warmest and the hottest and low rainfall of the bunch. So let's compare those and just notice that which desert you are matters because rainfall varies in the desert. So where are deserts around the world? Well, and you can see that there's a distinctive difference between the locations. So what is this type, the orange versus the yellow? Let's find out. Let's look at the desert subbiomes. An arid desert, probably the most familiar to you. Sometimes it's called hot and dry. You may think that hot simply refers to the temperature. It's not just for obvious reasons of hot and dry. Hot also refers to the type of precipitation it receives, which would be rain, if and when it has rain. So it has extremely limited rainfall, which typically arrives during the winter season. Extremely high temperatures exceeding 135 or 130 degrees Fahrenheit because they're along equatorial deserts and they receive twice as much solar radiation during the day. There's no subsurface waters in most areas. I will say that's not necessarily true in some deserts that have a great groundwater system, but in arid deserts it's virtually non-existent. There's like no soil hardly at all. Most of it's going to be sand. Flora is rare, meaning plants, but commonly you'll see small shrubs and thick-stemmed plants when present. The nocturnal animals, mostly reptiles and insects. As you would guess, the animals are nocturnal, mostly reptiles and insects, and virtually hardly any mammals. There are some very unique animals that live in the desert. There's actually a desert cat, if you want to look at that. They're very interesting. The inland Sahara is a great example of an arid desert, and it averages 1 to 2 centimeters of annual rainfall. Think about that. That's just little bitty amounts of water, so very dry. Number 2 subbiome of deserts is the semi-arid desert. These deserts are mostly dry and hot during the summer with light concentrations of rainfall between 5 and 24 centimeters. While they get some in the winter, monsoon season, which is usually July and August, is where most of their water comes from. On a global scale, rarely do temperatures exceed 110 degrees, with summer temperatures averaging between 60 and 80, so they can be very temperate. And winter months usually around or slightly above freezing. Soil types vary from gravelly and rocky to sandy, but in the United States, most of ours are made up of very much gravel. So while we do have some areas that are semi-arid that have sand dunes, gravelly rock desert pavement, very common. In your semi-arid desert, this is actually a shot of Monument Valley. You would expect to see small reptiles, insects, and a few mammals that live there. Maybe some mule deer you'll see in a semi-arid environment, coyotes, things of that nature. Small prickly shrubs and grasses populate the areas and store enough moisture through transpiration and can give back through transpiration back to the environment. The Mojave, Sonora, and Death Valley are all great examples of semi-arid deserts. There's still another type of desert called a coastal desert. Usually these deserts exist in the rain shadow created between a tall mountain and the ocean. This is sometimes referred to as an orographic effect because the eccentric features, meaning the tall mountains, create them. When averaged together, they possess odd weather patterns, with some locations recording minus 15 degrees Fahrenheit in the winter and a temperature ranging from 45 degrees to 85 degrees in the summer. So you can imagine that where you're located and altitude matters if you're on the coast or if you're up the mountain. The Atacama is a great example of a coastal desert. When we think of these places, they average about 8 to 13 centimeters of rainfall a year. Coastal deserts generally possess sandy soils with a high saline content because they dry up so fast that you'll get what's called a lot of playa lakes. So you get evaporites like gypsum and halite, which is salt. The thick-stemmed plants here sometimes breathe water vapor and through their little fibers on their leaves, adding more moisture back into the water cycle. And this picture shows one of these plants called trichome. So kind of a cool plant for the desert. There's still another type of desert called a cold desert. These regions are cold and are considered deserts because of their limited water that comes through of rainfall. And really, it does not rainfall in the form of a snow is what you're going to get in cold deserts. Moderate amounts of snow and ice accumulate during the winter, but little during other seasons. They get 12 to 24 centimeters of annual precipitation, and the winter temperatures are somewhere between 20 degrees to 35 degrees Fahrenheit with 40 to 70 during the summer. You're thinking that's not that bad. Well, it's still a very challenging environment because you don't have a whole bunch of plant life. Most of the area is barren rock with little or no O matter, but grasses and sagebrush populate some areas. So if there's a food supply, it's going to be in that grass and sagebrush. Without having an O matter top layer for your soil, you just can't grow grasses that are going to be in large supply. There's an extreme variety of fauna varying between penguins all the way up to coyotes, so it's kind of a fun desert to visit. The vegetation and lack of permafrost are what separate the cold desert from the tundra. That would be a good test question. They can be as cold as tundra during specific seasons, and probably the best example I could give you of a cold desert is the Gobi Desert in Mongolia. All right, questions. Why do biomes matter to us? Why did we have to cover all this stuff? It was a load of information about 6 different biomes and their subbiomes. What are some of the difficulties experienced when trying to catalog and categorize biomes? Hello, are you still with me? Wake up! The lecture was not that bad. I'll tell you, they improved from this point out. Biomes is a little cut and dry, pun intended, for the deserts, which we just ended on. So here we are at science servings. Yay! You're to your science servings. You know what that means. The Sahara Desert spans 12 countries. It's a big honkin' desert. The Atacama is the driest desert in the world. Deserts often contain large mineral deposits, especially evaporite deposits. Salty, shallow lakes sometimes temporarily form in deserts during flooding. Those are called playa lakes. 35% of Australia is a big old desert, and it's the driest continent on the planet. I've been there and can testify to that. Dessert is something you eat, and a desert is a dry place. But are all deserts hot? I'm going to leave you with that thought. A Barcan dune is a crescent-shaped dune just like this one. We have lots of Barcan dunes where we do have sand dunes in North America. In conclusion, think about all the biomes that we've had, how to categorize them, and how they're so very different but yet similar. That's the challenge in categorizing biomes. I'll see you in Lecture 3. Bye.